So just in time, we just started to go over the order. What? Oh, never mind. All right, so, I still didn't unfreeze it. Are we recording? Yeah, we're recording. All right, so if I have a variable term and a constant on one side, and then also a variable term and a constant on the other side, that is a what I call Mr. Gill's three-step equation. It's step 4 though. Here's the reason why I'm emphasizing that step so much. From there, you should be able to follow the pink sheet. I do not understand how you would not be able to follow the pink sheet from there. Now, I'm not saying you can't. I'm just saying it's not obvious to me where you could make a mistake, and nobody ever asks questions. So until somebody asks me a question and says, hey, I don't get this part, I expect that you can do it. So if you're not able to do it, ask me. Like, again, I'm not saying it's not possible to not understand it. I can't think of another way to teach it. So I need somebody, if you don't understand it, help, because I guarantee you're not the only one. Somebody help everybody out and say what you don't understand about the pink sheet. Because we're about to go through and use the pink sheet to solve this. So I want you to solve this out using the pink sheet. Again, now you know you're on step 4. So go to step 4 and try to solve it using the pink sheet. Don't sit there and do nothing because it's too late once you get to an exit ticket to try to learn how to use it. You need to learn how to use it on days when you don't have an exit ticket. So when you do have the exit ticket, you know how to use it. Oh, somebody didn't have enough caffeine.
No, the cat.
I told. Did you look into that money-making business I told you about, Willie?
Oh yeah.
Oh wait, we can't say all this house.
We all heard it.
Mr. Gill fired. I'll give you another. You may not be done with it by the time I start. I just want to make sure you. The main thing is start in the right spot. That's the main thing I want to make sure you know. But from there, like I said, once you know where to start and you're getting that right, you should be able to follow the sheet and finish it out. Because after you do the first thing, you're at a 2-step equation. So I'll start in a second after I get. Oh, I do have one. All right, so now let's talk about how to use the sheet. So once you know you're at step 4, again, you will always have a problem that looks something like this. Now, it might look like this instead. You could have 1 plus 2x on that side like that. Like, it doesn't matter if these terms are reversed. These are already kind of reversed. So that would still be what Mr. Gill calls a 3-step equation. So you can move them around, but the key is, so that separates sides. On the left side, you have a term with a variable and a constant. On the right side, you have a term with a variable and a constant. That will always be the case at step 4. And then from there, you solve it exactly the same way. Well, you follow the sheet. The math could be different.
I didn't follow the sheet. I just went on.
If you know how to do it, then I'm not going to force you to follow the sheet. But I'm just saying for people struggling. So on the sheet, it says, oh, one thing I will suggest, I didn't mention this, I don't remember. It says get rid of the variable term on the right. If that confuses you what get rid of means, you can say this means start with. It's really the same thing. You could just change or make that note. Huh? Well, it's not always the same.
Add or subtract.
Yeah, well, it says that after. It says do the opposite, add or subtract. So it says get rid of. If you need to add in there, get rid of really just means start with. Start with the variable term. If you don't know what that means, make yourself a note. The variable term, and I can't erase. Oh, I can do this. I just need to erase this really. There, now we can do it. The variable term is just something with a variable in it. Simple letter. That's a variable term. That's all that means. These are all variable terms. That's a variable term. That's a variable term. That's a variable term. That's actually a variable term. We have two on the same side. And that's a variable term. Anything with the variable in it, that's a variable term. Everything else is a constant. You only have two types of things. It's either a constant or a variable term. Those are constants. Constants don't have a variable. There's only those two different types of terms when you're solving equations, other than literal equations. Don't worry about that. So it says start with the variable term, so the one with the letter, on the right side of the equation. So that's where you would start. So if anybody has a question about that, now's the time to ask. I'll guarantee you some people do. You're not the only one. If you're willing to say what you don't understand about that, you probably help out other people. Nobody? All right, then I assume everybody knows what they're doing. So now it tells you, next step, you're going to add or subtract to get rid of that. So we know we don't have to worry about dividing or multiplying. It says you're going to add or subtract, and it says do the opposite. Well, if this is subtract 3x, then the opposite is plus 3x. And you'd always write the same number and variable, like plus 3x. Now, this is not written on the sheet, but what is Mr. Gill's most important rule?
Whatever you do to one side, you do to the other.
So you do have to remember that rule and know that if I do that over there, now here's a mistake I could see somebody doing. I'm not saying you're going to be perfect, because you're going to make some mistakes still. When you go to do that plus 3x on the left, don't put it underneath the 1. Like, don't do this, because I can't combine the 1 and the 3x. If I could have combined that, then I would have just combined these up here and these over here. We can never combine something that is just a number and something that has a variable. They're not like terms. Remember, they have to have the same variable or no variable at all in order to be able to combine them. So I can't combine those, but I can combine the 2x and the 3x. They would both have the letter x in them. So you need to write it underneath the term that also has the variable. Now, if I move something over without a variable, I'd write it underneath the one that doesn't have a variable, which we're going to do in a minute.
Which is what?
The constant, yeah, which we'll do that when we get to a two-step equation. So I add these, I get 5x plus 1 equals 2. And then this just goes to 0. I say it goes away. Technically, it just cancels out and goes to 0. But I don't need to write 2 plus 0, because 2 plus 0 is just 2. So now you're in a two-step equation. If you didn't get that, hopefully you've corrected it by now, but if not, correct it real quick. And again, now you're at a two-step equation. If you go to the top of the sheet, it tells you how to kind of finish it off with a two-step equation. It says start with the constant, and it again says on the same side with where the variable is. So we're going to focus on this side where the variable is. The constant is the one without a variable, and it says then do the opposite math. You should have written in the first time you do opposite math, you add or subtract. You don't have that written underneath. Well, actually, I'm not going to show that today because we're moving on to another topic. Then if I do it on one side, I got to do it on the other side. I get a 1 here. That goes to 0, so I don't need it. I bring down the 5x. You should also have written the second time you do the opposite math, you're going to multiply or divide. So if this is 5 times x, and I need to do the opposite, that would be divide by 5.
It's 5.
You can't write.
Like,
Oh,
it's 25%. It's 25.
So then point 2 actually, but you don't have to convert it. All you need to do is leave. If you get a fraction, you just leave it like that. You don't ever have to convert a fraction to a decimal for me. I don't even know if you're ever going to have to do that on like the PSAT or the SAT or the VOC. Like, I normally they put their answers in, like I looked through this book already. Well, that's because there was a lesson that is specifically on converting to a decimal. In algebra, normally Like just looking through.
No, I had pre-algebra. Think about it.
Well, yeah, you had pre-algebra last year. Yeah. But normally, like I'm looking at this, there are no now they might start with a decimal and then you have to give your answer in a decimal, but they don't normally have fractions and then make you convert into a decimal. Not in algebra. All right, so I'm not going to solve out the second one, but what step would we be at on number 2? Hopefully everybody has that. Is anybody still writing that? Not just yet. I want to get through all of these. Is anybody waiting though, by the way? You were outside. Hey, you didn't ask about math. You didn't ask about math. You've been outside. You can go out, but you hadn't asked already, is what I'm saying. So you can go after you. Yeah, that's it. This is not step 4 because we have the like terms. So if you have like terms, even though there's only 2 things on that side, it's different from up here. Here we had a constant in a variable term. Here we have 2 variable terms. So we can combine those. So we're actually at step 3. Some of you put step 2, which is still combining like terms, but technically step 2 is combining them on the left. Step 3 is combining them on the right. And remember, we never try to combine across. I never try to say, oh, well, this 3x and this 2x is negative x. I don't do that. That's where I have to like actually add or subtract underneath the equation. I'm a little concerned about our graphing still, so I'm going to go over this one a little slower than I did the very first time I did it. Like the first time I did it for classes yesterday. Here's the process, and everybody's good with the first, well, for the most part, everybody's good with the first 2 steps. We put a circle on the number, not to the left of the number, not to the right of the number, on the number, once you get your answer. We then say, do I need to fill that circle in? Well, if there's a little line underneath the or equal to part, then yes, we need to fill it in. So yes, we need to fill this one in. Now here's where a lot of people, like probably half the people got this wrong. More than half in some of my classes yesterday. I'm about to shade the side that is all the possible answers. Every number that I have shaded is a possible answer to this. Technically, that is an inequality. Even though there's nothing to solve, it's still an inequality. You have an inequality symbol. So when I shade it, every number in the shaded region, if I plug those numbers in for x, they should make that a true statement. So let's take, for example, I always test the same number. I test a high positive number because it's just really easy to see whether or not the high positive number works. So I'll test the number 10. It doesn't show like right here, but I know 10 is way out here. So I'm just going to test the number 10. So I say, all right, well, if I'm testing the number 10, is this a true statement? Is 10 less than or equal to negative 3? So I'm asking, is 10 less than or equal to negative 3? Oh, it's not a trick question. I'm just testing 10 to see whether or not it works. It doesn't work. That is not what? That is not a true statement. Well, if that's not a true statement, then 10 is not an answer. So if 10 is not an answer, none of these are answers. You only have to test one number. You can't have some numbers over here be an answer and some not be an answer. It's either all or nothing. So either all of them are answers or none of them are answers. So if 10 doesn't work, nothing works. So that is not the solution side. This is the solution side. It's always left or right. I mean, there's never once you know it's not, you can't go right, you got to go left. There's no other option, left or right, for these types of problems. Now, I could also test another number just to make sure, and I could say, well, let me just to make sure test a number that's in this shaded region. I could say, is negative 5 less than or equal to negative 3? Is that a true statement? So I'd write negative 5 less than negative 3, and I'd say, is that a true statement? Well, if I'm not sure how to do that, I could come over to a number line, or I could draw a number line. If you draw a number line on every test you take or every exit ticket, That's not a bad idea, just to make sure. But here's -3, here's -5. The higher up you are, the bigger the number, right? Because these are clearly bigger than negative numbers. So -3 is bigger than -5, or -5 is less than -3. So that is true. That is a true statement there, which it should be because I already tested 10, and that told me this side should be the side, and I just checked it and it did work. Again, I think half of you shaded to the right. I don't know why, so if you can explain why, I'll go over it, but I don't, like I said, I can't really correct anything if nobody's telling me what they're confused on. I think sometimes we just shade the side that has more room because we just think you always do that. That is not the case. Sometimes you will shade the shorter side. You need to pick a number to test it out, and that will tell you which side you shade. Somebody said, well, can't you just, this is a trick that teachers teach, so I'm going to show it to you briefly, and I guess you can use it if you're really, really, really confused. Some kids are saying, well, can't you just draw an arrow in to this, and it's pointing to the left, so that's the way you shade it. Some teachers will teach. Well, that works in this one, and it'll work in a lot of them. Won't work if it's like this, though. If somehow you solve a problem and you get the variable on the right, and you come up with something like that, well, we'll even do that. Pointing that way, right? That would be pointing that way, but the variable's on the other side, which means that would be the wrong side to shade. This is technically read as x is greater than or equal to -3, so you would actually shade to the right. Now, if you flip this around and you change it and put the x on this side, if you know how to properly flip it around, which it would be like that, so this is like this if you put the x on the other side, then you could still use that trick and say, okay, well, the arrow is now pointing to the right, but just be careful about that trick. Doesn't always work when you solve stuff out and the variable's on the other side. Somehow, I mean, I'd much rather, plus that's a trick. I hate tricks. I'd rather you understand what you're doing. The shaded region are all the possible answers. If you plug one of those back in, it should make the statement true. All right, any questions? Again, I spent a lot of time on that just because so many people have gotten it wrong over the last 2 days. And on the exit ticket last Friday, the majority of the points I took off were for the graphs. That I don't know. I don't have them memorized. I have a lot of kids. All right, so here's your new topic. So start a new page, or if you just want to start underneath where you're at. But you are on the new topic. So if you want to go ahead real quick, Daniel, and run out, then when you come back in, you get caught up. And then Willie, when he gets back, you can just trade your phone out for the pad. Or you can leave your phone on the desk. I don't care where it's at, as long as you don't go out with it. What's that? Yeah, I don't. It doesn't have to be in the
So is it so plug can come back so they don't want the
well, both. Because it's amazing how much longer kids spend out there if they have their phones in. I'll grab the pass. They don't go out there without a pass. Not that they check that often. Sometimes.
Oh, yeah, the
Oh, I'm sorry. Right now, you're just You're just writing this topic. That's all you have to write right now. If you don't copy all of that, I mean, don't erase it because you are going to come back to it. So if you've already written some of it, that's fine. But don't worry about writing it right now. Actually, everybody should be done with just writing compound inequality. So we'll be back to that in a second if you were in the middle of writing it. I want to explain a little bit first before we go into the graphing part. All we're really doing today is graphing. We're not getting into solving. We'll do that on Friday. So prior to today, when we were dealing with inequalities, we were dealing with inequalities that pretty much were that type of inequality. Well, I'll call it a one-rule inequality. Today, we're moving into what's called a compound inequality. And they're going to look more like, and there's all different kind of versions, but there's one thing that they will all have in common. It is different from what we've been doing. What is it? What is different from the ones in blue versus the one in red? Has nothing to do with the numbers or where they are, or negatives or positives. Doesn't have to do with the fact that this has parentheses and those don't. What is it? How do you know that? Well, this one doesn't have an or. How do you know that's two equations? No. Nope. Plus sign is actually not really separating.
But there's more than one sign.
That's what we need to recognize. So here's what you need to write down for your first note. If you see two, and the word, if you see a word and or, that's a dead giveaway also that you're doing a compound inequality. We've been doing inequalities and we've never seen the word and or before. So the first time that's appearing is compound inequalities. So the word and or the word or is also a giveaway, but more specifically, we have two of those in that problem. That is one problem. By the way, 6y subtract 4 is less than negative 16, or 2y plus 1 is greater than 9. We also have two, we don't have a word in this box, but we do have two of those again. So if you see more than one, or really specifically two, you're never going to see more than two. They're called inequality signs. So if you see more than one inequality sign in one problem, that is a compound inequality. And the way you do that's a little different than what we've been doing. The good news is the math is normally easier on these. They're normally much smaller equations, but technically they are two different equations in one problem. Even though this kind of looks like one, it's technically two. Yep, I'll say it one more time. Anybody still writing what I just said? And looks like everybody. All right, so if you see, I guess we could just say two inequality signs. I was going to say more than one, but you'll only see two or one. So if you see two inequality signs, and inequality signs are these, and the word inequality is here, you would just write a Y instead of IES. So these are all inequality signs. That's the four different types. If you see two of those instead of just one, and it could be any two, it could be both of these, it could be this one twice, this one, I mean, it doesn't matter, just there's going to be two of them. That is a compound inequality. Until we get to one other lesson called a system of equations, or system of inequalities. So this is technically, so that means you technically have two separate inequalities, which is easy to see here. You have this one. I'm going to get, is anybody writing any of that? I'm starting to get cluttered. So here, that's one inequality separated by the word or, and there's the other inequality. So each symbol has its own kind of equation or inequality with it. In the other one, though, it's a little tougher to see what the two inequalities are here because it's all on one line. There's no words separating them. So here's how this one would read. I would say this is 3x plus 10 is greater than 4. So I'm taking that middle section and saying this middle section is greater than 4. So using that symbol. But then this is where the word and comes in. And 3x plus 10 is less than or equal to 16. So that's how you would read there. But we can write this like this, so you won't always see the word and. Sometimes you will. Sometimes they'll give you the word and, but sometimes they won't. So just know that if you see two symbols, even if the word and is not in there, that's still a compound inequality, and it's also an and inequality if you don't see the word and. So really quickly, I'm going to explain what this is, but don't just listen. Don't worry about writing anything down. Just try to think about what I'm saying because we're about to do a more visual lesson on it. The difference between having an and or an or. I'm just going to see if you're going to try to sneak out with your phone. So the difference is these are both rules. Like we say an equation is a rule, right? This is a rule. 3x plus 2 has to equal 7. The left side has to equal the right side. Well, this is also a rule. We are saying this, so the left side has to be greater than the right side. So it's still a rule. Here we have two rules. So here's the difference. Oh, write this down, by the way. In a compound inequality, you have two rules. So two inequalities means two rules. And they're rules that we have to follow. Sort of. Done. So in an or, with an or compound inequality, we still have two rules, but we don't care which rule we follow. As long as we follow at least one of those two, then that is an answer. So when we solve this out, we're going to actually get kind of two possible answers. I'm going to solve it real quick. So plus 4, oh, negative, let me write larger. That will be negative 12, 6y divided by 6 divided by 6. So y is less than negative 2. So that's one solution set. Or if I solve this out, subtract 1, 2y divided by 2, y is greater than 4. So those are my two solution sets. Y could either be less than negative 2, all of those are possible solutions, anything less than negative 2, or y could be greater than 4. So anything greater than 4 is also a solution. So I have a whole bunch of solutions. Everything less than 2 is a solution, but also everything greater than 4 is a solution. I have more solutions than an or. I'm going to get rid of this. Hopefully you have that written down so I can solve it underneath. When we do an and, it's a little different. Our solution set is going to get smaller. And I know you're doing a lot of notes right now, but you'll get to a point where you're about to do something in a second. So now, don't worry about how I'm solving this out. Don't even write, again, you don't have to write notes on what I'm about to do. You're going to get to this on Friday. So I'm going to subtract 10 from everything. I get negative 6, positive 6, 3x divided by 3, divided by 3, divided by 3, 2. How am I will write the final answer differently. So we get x is greater than negative 2, and x has to be less than 2. So here's the difference when we have an and. We still have two rules. In an and compound inequality, we have to follow both rules. Here, we don't care. If we follow this one, we're fine. So anything less than 2 is a solution. If we follow this one, we're fine. So anything greater than 4 is also a solution. Here, though, we only want the numbers that follow both of those. So we need to be greater than negative 2 and less than 2. Give me a number that works.
Less than 2 and greater
So
than
0. Somebody said 0. Is 0 greater than negative 2?
Yes.
Yeah. Is 0 less than 2?
Yes.
There it is, 0 is less. So 0 works. 0 is a solution. Now let's come up with a solution that doesn't work, but it works for one of them, but not the other one. Really, any number you take. What was it? 7. Is 7 greater than -2?
Yes.
Yeah, absolutely. 7 is greater than -2. Is 7 less than 2? No. So 7 is not a solution if this is an AND problem. Because it's got to work for both of them. And it didn't. It only worked for one of them. Over here, though, well, actually, one word there. Let's say we change this to OR. If we change this to OR, 7 would be a solution. Because 7 didn't work for this one. It's not less than 2, but it did work for that one. So we would say if it was an OR problem, that 7 is a solution. So see how your solution set gets bigger. If you don't understand that, don't worry too much. We're going to go over that more on Friday also when we solve. Any quick questions? The main thing to get out of it, you have 2 inequalities, so 2 rules. If you didn't write it down, you probably do want to write in an OR statement, we only have to follow one of the 2 rules. So if you didn't write that down, in an OR statement, we only have to follow one of the 2 rules. We don't care which one, we just have to follow one. We can follow either one of them. In an AND statement, we have to follow both of those 2 rules in order for it to be a solution. You'll see, I think, when we do the graphing, what that looks like visually. I think that's the easiest way to see it. So, in an OR compound inequality, you only have to follow one of these, and it's a solution. So in an OR, you only have to follow one of the rules. Doesn't matter which one. If a number follows this rule, it's a possible solution. If it follows that rule, it's a possible solution. For an AND, that number has to meet both of those 2 requirements, both of those rules. And you'll see something that'll happen when we do the graphing and verify some stuff. So now let's go back to the ANDs. So now here's what I want you to do. When you graph, whether you graph an AND or an OR compound inequality, it doesn't matter. The process is the same. Your final answer could be different, but your process is the same. You're going to have 2 graphs every time. One is your first graph where you're kind of putting both of them on the same graph. Then you're going to have a final graph. That's your answer. This second graph is going to be our answer. So we'll do that together, but what I want you to do, graph both of these. So graph this and graph that on one graph. So again, you're only using one graph to do this part. Graph this, so you'll put that on the graph, then do this same one on that same graph. So you're going from -5 to +5 if you can't read the numbers. And I'm going to show you a very specific way to graph that will hopefully make this easier to do. Yes? Yeah, I don't think anybody's waiting. Nobody. Oh, wait, no, I'm sorry. Willie's out. Willie's out. If he's not back in a minute or 2, then I'll let you go. So graph both of those. Make sure you pay attention to whether or not you fill the circle in, and then you need to be able to figure out which direction you go, which we just practiced on Miller. This is my middle school.
Oh, okay. It's like,
They're called like Little Middle School Lightning. This is down in Manatee, Bradenton. My first year teaching, 8th grade. All right, so when you graph these, this is the way for a because remember, you're putting 2 rules or 2 inequalities on one graph. So in order to make your final graph easier, I'm going to show you what works pretty well. There's 2 ways I'm actually showing you. First of all, though, we got to say, okay, well, here's my number, -2. I start with an open circle there. Then I look at the symbol. Do I have the line underneath?
No.
Nope, no line, so I do not shade that in. Now I need to figure out which direction I go. I need the numbers to be greater than the -2, or I can just plug a number in and test it. If I test, I normally choose 10, but I'll choose 3 since it's on the graph. And I think, well, is 3 greater than -2? Is that a true statement? Yeah, that's a true statement. 3 is greater than -2, so 3 is a solution. So when you shade for a compound inequality, you need to be a little more careful. Shade on the top of the line for your first one. And I'm going to show you another way to do that also that's still on the top, but it looks a little different. It's actually the way I see a lot of kids doing it. So I shade on top for that first one. If you have colored pencils, you can also do it in 2 different colors. That works really well. Or even pen and pencil, but then if you mess up, you can't really erase the pen sometimes. So now, oh, I'm still going to do it in the same color. So now I need to shade this one. I need to graph that. Well, the number is 3. I do have the little line, so I need to fill that in. And it needs to be less than. So again, now if I pick a number to the right, I just like dealing with positive numbers. I mean, I could pick 1, I guess. I guess I'll pick 1. Is 1 less than 3? Yeah, 1 is less than 3. Is that a true statement? 1 less than or equal to 3. Yes, that is true. Well, that means 1 is a solution. Now I'm going to shade underneath. So I go to the left, but underneath, because this is the second equation I'm now graphing. So, oh, and I would need the arrow. This is actually where we're going to, I told you about making sure you put the arrow on there. This lesson is why we put the arrow in the other lesson. So, now what I got to do is I got to figure out what's my final graph, because my final graph is not always going to be the same. Sometimes it will, sometimes it won't. We said that the number, if it's an and compound inequality, we said the number has got to work for both of those. Not just one, but both. Got to work for this and for that. So let's just test out some numbers. Somebody give me a number. 4. Somebody said 4. Is 4 greater than -2? Is 4 greater than -2? Yes, 4 is greater than -2. Whoever was asking, raise your phone out.
Can I pull out there?
So 4 is greater than -2. So we met the first requirement. So we said check. Yep, we met that requirement. But I got to meet both of them in an and. So is 4 less than or equal to 3? So if I wrote 4 in, is, whoop, wrong place. Is 4 less than or equal to 3? Is that a true statement? 4 less than or equal to 3? No, that didn't work, right? Well, if it doesn't work for both, it is not part of our solution. So our final graph will not include that section of the graph. Oh, and there's, if you didn't notice, there's kind of 3 sections. There's a section to the left of this circle, to the right of that circle, and then in between the 2 circles. You're always going to have 3 sections, really, on any compound inequality we do. So now, somebody give me another number. 2. Okay, good. 2, and I don't want a number that was in that section because that section doesn't work. So 2 is in the middle section. All right, let's test 2. Is 2 greater than -2? So is 2, is that a true statement? 2 is greater than -2. Hopefully I should see more heads nodding yes. Yes, 2 is greater than -2. Is 2 less than 3? Is that a true statement? Less than or equal to 3 technically. Yeah, that works, right? We said yes to both of those. We said that makes both of those true. So this section will be in our final graph. It worked for both of them. Give me a number that's in this last section.
4.
-4. Gotta be a -4. This is negative. We're in the negatives. So is -4 less than -2? I'm sorry, is -4 greater than -2? Sorry.
Yes.
Is that a true statement? -4 is greater than -2.
Yes.
Remember, the lower it is, the smaller it is.
Oh, no.
-4 is down here. -2 is here. -4 is not greater than -2. So this is not true. So I already didn't meet that one, which means I don't even need to test the other one. It's got to work for both. So this section will not be on my final graph. So when I go to do my graph, I now know I don't include those two sections. The circles are going to really be the same pretty much every time. I don't think there's ever a situation where they're not. So it'd be a closed circle there, open circle there, because we could even test it. Does 3 work for both? Is 3 greater than -2? Yes, 3 is greater than -2. If I plug in 3 here, is it true that 3 is less than or equal to 3? Yeah, because 3 is equal to 3. So it worked for both. So they're always going to be the same. If it's open here, it'll be open here. Close here, close there. And then we said the middle section. So that is your final answer. You just graphed the solutions for that particular compound. Any number in that shaded region works for both of those. Any number not in that region will only work for one, but not for both. So now let me give you a shortcut version, now that I spent all that time on it. What's true about that middle section up here in this graph? What did I do in that middle section that I didn't do in the other section? Visually, how is that graph, how is that middle section different visually from the far right and far left? What's that? What do you mean 2 lines? Yeah, what do you mean 2 lines?
Talking about the arrows.
You're talking about the arrows on the end? Well, how is, and don't worry about the arrows, because this would never have arrows in the middle of, because I mean, there can't be an arrow here. I mean, if I've got an end of a graph, it's always going to be on the other section. What else is different? I thought you were actually saying the right thing. You may still be kind of thinking right. What else is different in that middle section? What did I do differently in there? How does it look different? When you look at it, there's something. Wait, what'd you say? What do you mean one is shaded and one is not shaded? You're getting closer, I think.
The numbers in right.
They are, but visually, there's a way you can tell that without. Remember how I just tested numbers? I tested a number for each section. There's a much faster way to do it. I know you guys don't like doing a lot of work, so this is the fast way. Visually, how many times did I shade this section? No, I shaded it once, right? I shaded underneath. So I shaded it once. How many times did I shade this section? Did I? I shaded above. Did I shade below? Not on the far right, I didn't. This section, though, I shaded above, right, for the first inequality, and I shaded below. They overlap. Those lines overlap. That section was shaded twice. That's always your answer. Wherever you shade twice, wherever you have overlapped lines, that's your always. So you write that down. Wherever your lines overlap, or wherever you use your own words, don't write what I'm saying. Wherever you shaded twice, wherever your lines overlap, whatever you need to write, however you explain what we just did, that section will always be for an and. This is only for and. And is where you shade twice, because we have to meet both rules. This is visually meeting both rules. The answers are the shaded regions. So we have shaded regions for both. So whatever you need to write, and that's a big one. Like that saves you a lot of time when you're doing graphing. You can just look at the graph and say, okay, well, I got lines overlapping right here. That section is my answers. You don't have to plug numbers in and do all that. Phone up. You know who you are. You guys are on this list, so you really need to be putting phones up. You never will get off that list. And I'll tell you why. Does anybody know why? Like, because I have a no phones rule. Why is this important versus just the normal no phones rule? Can I explain that?
No.
I think I have, but I don't think you truly get it. So guess what the other classes got to do for the last 10 minutes of class?
What?
They got to take their phones out and just do phones. No work, nothing. Guess what you're going to do for the last 10 minutes of class?
What? Work?
We're going to work all the way through.
Man.
Yeah, that's why you don't keep sneaking peeks at your phone, and that's why you work when I tell you to work. So, and you can get off that fairly easy. Normally you have one really good day and I take you off of it. But if I haven't told you how to get off of it or why you're on it or what the difference is, now I have. So, and I just saw a couple of people actually peeking phones. All right, so that's your final graph. That's what an and is. We're going to do the other ones really fast. I spend more time always on the first one. So here's what you do. Process is always the same. I don't want you to be able to see that one. All right, tell you what, that'll work. So you're graphing these two now. So graph them both on one graph. That's your first step. And that's always your first step. Even when we go to the or compound inequalities, still going to be your first step. You put them both on one graph. So graph them both on one graph. And then if you think you can do it, graph what your final graph would be, your final solution. Remember, for an and problem, the final solution is where they overlap. I'm going to show you a different way, by the way. It's no, not on this one. I'll do it on the next one. I'm only going to give you like a minute to do this. It shouldn't take long now that you've kind of seen a long explanation on one of them. You're all right. Different. You like being up amongst things. All right, so I'm going to go ahead and get started. You can keep working and just kind of check yours when you get done. I'm going to go over it, so you got plenty of time. Just keep working. So same process. We're going to put circles on the numbers. My graph or my numbers, my answers need to be less than -1. So these are the numbers less than. Put an arrow on the end of it. There's one graph. So I put a circle on +2. I do not shade that one in, the circle. I need to be greater than +2 for that equation. And there's that. So now I need to create, did everybody get that? Like, raise your hand if you didn't understand what I did. Yours is not matching up with that. So from -1, you should be going left. From +2, you should be going right. You can get partial credit, by the way. If you give me the first graph correctly, but then you can't do the second graph, the final graph correctly, I'll still give partial credit. So don't ever just give up because you're not sure how to do the final one. So what's the final answer? Where do I shade? Final answer. So what am I going to put on the big number line now? Yep. So put a circle on -1 and -2. Remember, the circles would always look the same. We'd never fill them in down here if they weren't filled in up there.
Draw a line.
Draw a line.
Graph 0, 1, -1, 2.
Know what everybody got? 5 line stairs. Now, did you do that by plugging numbers in, or did you do that by like doing the visual thing? But how did you know that was the answer? That was a section sheet. How did you?
I can use circles.
That's not how we do it.
But it gives me the real.
Was it?
Yeah.
Yeah.
Mostly possible.
Let's see. Zeros in you're saying zero is an answer. It's going to meet both of those. You say. Is 0 less than 1? Negative 1? Oh, that didn't work.
So that's going outward.
So again, there's two ways to do this. I can test numbers from each section. Or what did I say about the shading? What has to happen for it to be a final answer in an and compound inequality? The last thing you should have written down. How do we know visually which section is the answer? If we do what? Say it louder. We shaded it twice. Where did we shade twice? Where did these lines overlap? Nowhere, right? This line never crosses over the top of that line or underneath it or anything. And if we test each section, let's test -4. Is -4 less than -1? Well, yeah, -4 is less than -1. Check there, but it's also got to meet this one. Is -4 greater than 2? Absolutely not. It'll work for one of them, but not both of them, which means it doesn't work for an and compound inequality. So now let's test, well, we just did test 0. We said 0 isn't less than -1, so it didn't work for that. Quickly, 4. Is 4 less than -1? No, 4 is not less than -1. So neither of those worked for this one, so we're done. We don't have to test the other one. There is no number that works for that. And think about it. I would like for you to give me a number that is somehow going to be less than -1, but then it's going to somehow be greater than 2. How can you have a number like that? No number is less than -1, but they can somehow be greater than 2. But also just kind of makes sense if there's no solution. So your final answer on this, there is no graph you can draw. So there's no graph. That's your final answer. There is no solution to that. So you would just see on it, you would either write that if you have to fill it in, or more likely it'll be on like a PSAT, SAT, that kind of stuff, and it'll just say no solution. They'll still give you some graphs, like they'll probably give you this graph. That would be one of them. One of the graphs might be just the right side, one of them might be just the left side, and then one of the options would be no solution, and that one would be no solution. All right, so now do the next one. Right there. So you're graphing both of these on one graph. Then your final graph is where the lines overlap. Or you can plug in numbers for each of the sections. Once you do a few of these, they should get pretty fast. Like if I've already given you the answers, which I think on the quiz or the exit ticket, I already give you the answers. Sometimes you've got to solve two different equations to get to this point. Those take a little bit longer, but we won't have that on the exit ticket. You're just going to either be given the answer and then you graph those just like we're doing right now, or you're going to have to solve, but you won't have to then graph. And we won't even get to that today. That'll be Friday. So you should be done with at least one of those by now on your first graph. Already finishing up your second one. You better do it.
Are you guys figuring out
Well, but that doesn't mean you just don't do anything. That's not the purpose. I don't take my time and stay after school so that you guys can not do anything in class. Now, I will be here no matter what. We're making up the test today. But, all right. I know stuff's going on. Oh, you're in trouble?
No, I thought my mom dropped stuff off and I have to find it now.
Oh, for that.
Yeah.
I'm sorry. I thought that was one of the ones from the, like, you know how they'll call kids out of my class for like.
Yeah, it is calling me out, but it's not for that.
Oh, okay. Yeah. No, that's fine. You can go then. Yeah. Did you ask me that already? I missed it.
The lady said I couldn't go because it says to go after the period, but I do that stuff right now.
No, that's enough. All right. Quickly, I'm going to do this one fast. If you have questions, though, ask. If it's not very, we'd call crystal clear. Really good movie with that line in it. It's a whole another topic.
Should I bring my stuff?
Where's your next class?
I have one.
Oh, then that's up to you. I mean, I'll be here. So we need to be less than -3. So I'm going left. We need to be less than 4 also. Open circle. Oh, shoot. Here, I'm going to show you another way to graph. I'm sorry, another way to shade. This is a way that actually I see students do a lot. So apparently some teachers teach this. Instead of shading like that, they draw lines. They do this, and that's their shading. So that's pretty clean. Like, I like the fact that there's not a whole bunch of scribbling, because sometimes when people scribble, they get a little confused. If you're going to do it this way, make sure you draw the line all the way to the end of the number line, because otherwise you don't necessarily see where they overlap. It's easier now to see, do they overlap over here? Do those two lines overlap? Hopefully you're thinking to yourself, no, because there's not any lines at all over there, so they can't overlap. Do they overlap here? No, there's only one line. The only section that is my answer is where I have 2 lines, 2 shadings, because this represents shading left and shading left. Is the number 3 going to be included in that? Is the number 3 a solution? So basically, should I shade that in? Definitely. Did I shade it twice up here? Open circle means it wasn't shaded. Whatever the circle is up here, it's pretty much going to be done. So if it's open up there, it needs to stay open down here. So now I could go ahead and say that's my solution, because I have 2 lines. The section where I have shaded twice, or 2 lines, whatever you want to call it. That is your answer, your final graph. For an and, again, this is all for and. We're about to move to or. But the process is the exact same. It's just when you do your final graph, you have to change one little thing. So I'm not even going to do the next one. It's the same process. Yeah, same process. Instead of them both being less than, they were both greater than. So let's move on to or. So now you may want to write out to the side, write the word or. So you know you've moved on to kind of a different, still compound inequalities, but now we're graphing or's compound inequalities. So here's the only difference. The process of creating the first graph is the exact same. Nothing changes at all on your first graph. The difference is when you go to do your second graph, the answer is different, because now we're dealing with a statement that uses the word or instead of the word and. We said if it's an or statement, either one of these could be true. If I put one check mark, if I put a check mark here, but an X here, that still works. If I put a check mark here, but an X here, that still works. So I'm going to have more solutions. So with that in mind, graph both of those on your first graph. I'm going to create a second graph while you're doing that. So if you didn't see what the inequalities were, X is less than or equal to -2, or X is greater than 3. So I'm going to create a graph we can use. There. Now we can use both of those. Oh, you can't see them. There. Oh, let me freeze it. All right, so you should be pretty much done creating the first graph. You tried to create the second one. Remember, it is not an and, so it wouldn't be created the exact same way. It'll have a different solution, a bigger solution. So, when I graph the first one, circle on -2. Do I fill that circle in? Yes, there's a little equal to or equal to guy under there, so I got to fill that in. It needs to be less than or equal to -2. So less than would be this way. I'm just going to kind of do it like that. So then I create the other one, greater than 3. Do I fill that one in? No, there's no little or equal to underneath. I'll still do it underneath. So that's my graph, my original graph. Now, if this were an AND graph, it'd be one of those no solutions. Those lines don't overlap. But that's not the way OR works. It doesn't have to meet both of them. Any section of this graph that meets at least one of these two is the answer. So if I plug in numbers, I would say is -4 less than or equal to -2. Well, again, if I thought about vertically, it's lower. So yeah, that works. So here's the thing. As soon as it works for one of them, it's a solution. You don't have to keep checking. So this is a solution. This is going to be on our final graph. This section worked for that one, so it automatically goes down. Only has to work once. That's the difference between the OR and the AND. So I'm done with that section. I can erase that. Now let's test the middle section. Is 0? Well, is 0 less than or equal to -2? Is that a true statement? Is that true? Oh no, 0 is greater, so that didn't work. So it didn't work for that, so it's not a solution yet. Is this a true statement? 0 greater than 3? No, 0 is not. So that didn't work for either of them. That's the only time it's not a solution for an OR statement, is if it doesn't work for either. So this section here is not a solution at all. So let's test the last section. Oh, need long arms. Is 4 less than? Is that a true statement? 4 is less than or equal to -2. Is that true? Is 4 less than? No, that's not true. But only has to work once, so it didn't work there. Is 4 greater than 3? Hopefully you're nodding your head inside. Yes, yeah, it did work for that. Only has to work once. This is part of my final graph also. So my final graph is actually the same exact graph. So that, and then this, nothing really changed. That's same exact graph. So now let me ask you this question. Visually, without having to test numbers, what would you say you could do, or what do you see that will tell you just to go ahead and create your second graph? What are you looking for? Anybody explain it? You could test numbers in all 3 sections, and if it works for either section, it's going to move down. What's another thing you could just look for? Because either you're shy and you won't answer, or you're not sure, or you're not sure enough where you don't want to put yourself out there. No idea. Let me ask you these questions. Did I shade this section at all? Was there any shading in this section? Yeah, once, right? Did I shade this section at all? No. Did I shade this section at all? So, anybody want to finish it off? What? See, if I offer, as soon as I offer food, we start answering all. So here's your statement for an OR. If you graph any section at least once, it can be twice, but if it's at least once for an OR, it's part of your final solution. Because the only section we didn't move down is where we had zero shading, I should say. If you shade a section at least once, so it could be once or twice, then it's part of the graph. The only thing you don't include is something with no shading at all, which was this middle section. We had one shaded region, they both moved down. Sometimes they'll overlap, which you would still bring down also, but you don't have to have it shaded twice like you do for an AND. It's just got to be shaded once, because if it's shaded once, it means it meets one of those two, which is all we need. So with that in mind, is anybody writing So do this one on one graph and then do it on a second graph. That's going to be a little bit of a unique answer, so see if you can kind of figure out what it would look like. Or there's actually a way to say it without that. Kind of like we did no solution, there's a way to say that, not actually create a graph. But there's also a way to graph this one. Either way would work for me on quiz. I'm going to only give you a few seconds and we're going to move on to it. And now I'll give you one. Sometimes I go too fast thinking that we're all getting it. Next thing I know, we're not getting it. I don't want that to happen. I'll force somebody to ask me something. I guarantee you something. Wait. Yeah, maybe I'll ask you. Getting it? Hmm? Good, then you can explain this one. Prove me you do, and then you go back. Well, those are just multiple graphs just for me to use, but this is what we're going to be graphing. So you're going to put both of those on one, then we're going to create the final one. So think about it. I don't care if you don't do it as long as you understand it. My only goal is that you guys understand stuff. Everything you do is just for me to see if you're understanding it. You sit there and do absolutely nothing, but then you get hundreds on quizzes. You sit there and do nothing. They're not wild about that in the department. You're not in trouble for them. Get it, you get it. That's all I care about is you do it. It's very rare that somebody sits there and does absolutely nothing and still do it. All right, what's the first thing we put on there? What do I do? We're going to do this one first, then we'll do that one on the same graph. First step. So I'll go ahead and rearrange those words and say we put a circle on that too. Which direction do I go? Got to be less than 2. Which direction would that be? All the numbers left. Yeah, these are less than 2, right? So I go that way. Now I got to do the other one. What's the first step? Do I shade either of those in, the 3 or the -3 or the 2? Yeah, there's nothing underneath, so I don't need to shade either of those in. So which direction do I go from the -3? These are bigger than 3, right? If I tried one of these numbers over here, 5 is greater than -3, so it needs to go toward that 5 or whatever number you chose on that side. Oh. So now what did we say about our final graph? What has to be true for an OR statement? We could test numbers, but I'm not even going to test numbers. What are we looking for visually? Quietly say something. Boy, I'm gonna put them on the spot and they're not gonna like it. That's something. I'm gonna ask Elmira. Oh, she goes, no. Elmira, what are we looking for to know that we need to move it down when it's an OR statement? I had you write it. Should have it written for an OR statement. What are we looking for to know? Yes, we need to move that down to the main graph. Have it? You write it down. Okay. What did you say that? Yeah, it's gonna look a little different, but really kind of. You tell me, where is the section I didn't shade? Did I shade? Is there a line going all the way out to the left forever? Like basically from this circle out to the left forever? Is there a line on that side? Yeah. So if I look at this section, remember there's always 3 sections. From this circle left, in between them, and then from that circle right. Well, there's I shaded. That's what this is. That is shading. So yes, I shaded at least. I'll only have to shade once. Doesn't have to be twice. Yeah, I shaded this section once, but that's enough. Is there shading in this middle section at all? Yeah, it's 2 times in that section. So if it was an and, that would be the only section that was my answers. But in an or, I just need to shade it once. Did I shade at least once on this last section? Yeah, going to the right. I have a line. If you see a line or shading, depending on how you're shading. When I say a line, I mean that represents shading. If you have shaded that section at all, then it's part of the answer. So we need to move all of that down. So is there anywhere I didn't shade? There's no number that exists. Give me any number if you think there's one that exists that isn't going to be in one of those sections. I can't think of one. So this is what you could do. So you don't need the open circles anymore, because even though that was an open 3, we shaded it right there. We went right through it with that line. Even though that's an open circle there, we shaded it with the other line. So it is included as just a normal shaded region. So that's one way you can do it. I would bet on the PSAT and the SAT and all those when you take it, they're not going to give you the correct graph. They're going to write this. So write this down also. The solution set is called all real numbers. Just means it's every number. There's no number that's not a solution. They might give you the graph and shade the whole thing. I wouldn't be surprised if they kind of test you to make sure you understand what this means, which means this all real numbers is the same thing as a graph that looks like that. Everything's shaded. That's the solution to this, like visually. This is actually the answer, by the way. When you solve out an equation, if it's an or statement, you're going to get something like this. X is greater than, less than, whatever, some number, or X is greater than, less than, a different. But then when you visually graph that, it's going to look like, for this one, it's going to look like that. Any questions on that? All right, let's do one more. Yeah. This will be different. This is a different one. So again, you put them both on the same graph. It's an or. So once they're both on the same graph, any section that has been shaded at least once will move down onto the final graph. Oh, well, let's finish. Yeah, I'll say it tomorrow. Ooh. You need to tell you who needs to make up quizzes still. Hopefully you know, but you did yours. Ewan's not here. Elmira, you still owe me the big quiz. I'm taking the big quiz, which is killing your grade. Kills anybody's grade. So you have this week, which is pretty much over. So what's going to happen is next week, if you haven't come in this week to take it, when I see you next week in class, I mean, I'm going to wind up giving it to you in class. You're going to have to make it up. You can't take a 0 on it. So you'll miss the material that day, but I can't have you taking a 0. So you need to, if you don't come in and make it up with me over the net, like if you haven't watched the videos and prepared and come in and make it up, then you need to make sure you prepare over the weekend for next week. And I don't want you to just come in and make it up this week just to get it out of the way. You need to watch the review video. September 14th is the review date. You want to look it up on my YouTube. Next week's the last week, but I don't take grades all the way up until the last day. The last day I'll probably take grades will be probably Tuesday. Now, luckily for you guys, you don't have anything to make up. I don't give homework. It's the only thing you would normally have to turn in. So it doesn't really affect you unless you're missing a quiz, or if you want to make up one of the exit tickets, because just because it doesn't say missing doesn't mean you can't make it up. If I haven't gone over this, if it's one of these little guys for an exit ticket, you can make that up. You don't have to. Remember, those are normally easier, so sometimes it helps your grade if you make them up. So if you missed today where we did an exit ticket and that's in the grade book, that's not hurting you, but if you studied for it a little bit, you could probably come in and help your grade out a little bit. But I'm not going to force you. That's going to be on you. I will not give you an exit ticket next week. You need to do that on your own time. You won't do it in class. You either need to come in at lunch, which normally for these, you have plenty of time at lunch, or you can come in right after school. All right, so let's do this one. Oh wait, was anybody else missing it? No, just you and not here, so just don't matter. All right, so on our first graph, circle on the 3. I should be making you guys do this, but we'll do that maybe a little bit on Friday. Circle on the 3. I then say, all right, I need to be less than or equal to that 3. Or if I plugged a number in, is 0. Is that a true statement? That 0 is less than or equal to 3? Well, yeah, that's a true statement. So that means I need to shade. Oh, no. Nope. Oh, yep. There we go. So I shade that way for that one. I then put a circle on that. Which way do I shade now? Vito, left to right. Point. Yeah, I gotta be less than 1, right? So I would go left again. Now, this would be a different solution if this was an and problem, because we would have to have both areas shaded. So this would be the solution section. This is an or. In an or, all we care about that it was shaded at least once. So once or twice works. So Katerina, what's my final graph going to look like? Did you do it? All right. And you're 4 minutes left, and now you're just saying that. I mean, I'm glad you said it now, so let's go through it. Do you understand graphing the first graph? Like taking each of these individually? Okay, well then you're fine if you understand that. So now you just look, so this is again for an or statement. Where do I have, let's say this. Where is the section where I didn't shade at all? Like there's no line above or below the graph. Yeah, to the right of the 3, right? That's the only section that has no shading. If that's the only section that has no shading, everything else is part of our solution, because that means there's at least one shaded line. 3 is included because it's circled in, so that's included. And I have at least one line there, and here I have 2, so that's definitely included. So that would be my final graph. So for an or statement, if it has any shading at all, then it's included on your final graph. And the only section that doesn't is that section all the way to the right. Again, that is for an or. If it was for an and, this section would have been our solution from -1 left, because that's the only place that has 2 shades, 2 shadings. Boy, I feel like now I need to make you guys do one more since that wasn't clear. I know there's somebody else that's gonna put it on there, and I'm gonna think everybody's got it because nobody's asking questions. Somebody's gonna more than one. It'll be a few people are not gonna get the graphs right, but I can't really. If you're not saying anything, there's not much I can do. I walk around every single time we do this, and we don't get through enough material. Oh, I didn't do. We should have done whiteboards. Maybe we'll do whiteboards. That way I can look real quick. All right. So, just does anybody have like? And again, you're the ones that have to take this exit ticket on Friday. you will have probably one more. I don't know that we'll get two more in. So you're going to have the one on Friday, and then probably one like Tuesday. We'll probably have to do one immediately because I'm not doing a whole bunch of grades. Maybe I can push it. Any questions? Last chance. I almost checked your ears. All right. No phones though. Don't pull your phones out. You're still. I will take you off after today, even though I still saw some people looking occasionally, but it wasn't horrible, I guess. So the exit ticket will be at the end of class as usual. We still have new material that we'll do right before it, but I'll grade that section pretty easy. Like I won't be real hard on that section since it's the same day that we're